All right, so on to the third way of simplifying trig expressions. We are going to go to do factoring. We have the GCF. We have the difference of two squares, which is dots, the difference of two squares, and finally quadratics. So if I look at my first example here, if I have the sine of x, cosine of x, minus cosine of x, you cannot combine those two cosines. What you have to do here is your GCF is the fact they both have a cosine of x in it. So you take that GCF of the cosine of x out, and then you are being left with sine of x. Now be careful here. The cosine of x, when I take that out as a GCF, that's left with a minus 1. That's really all I can do with this right now, but that's an example of how to go ahead and factor out a GCF. Now, I have another example with a GCF. My next example with the GCF will be the sine squared of t times cosine squared of t minus cosine squared of t. Same thing here. Only this time with this question, my GCF is my cosine squared of x. So I'm going to take that cosine squared of x out, cosine squared of t out. And what I'm left with, the first one again, this is taking out the cosine squared of t. I'd be left with the sine squared of t, and cosine over cosine is equal to 1, so that's minus 1. Now, with this, we got to be really careful. What do we see here? That's that, always keep an eye out for these. This is one of those Pythagorean identities. So sine squared minus 1 is equal to, all right, so let me go ahead and just, the identity is that you have the sine squared of theta plus the cosine squared of theta is equal to 1. So I want that to be a negative 1 this time, right? So because I want that to be a negative 1, what I want to do is I want to move the cosine over and the 1 over this way. So now I have that this is the sine squared of theta minus 1 is equal to negative cosine of theta. So that's what I'm going to replace that with. So that gives me my cosine squared of theta times, that's my negative cosine of theta squared. Got that 2 over there. Now, because and only because that a t. Oh, this is good. Let me fix that up. I'm replacing it for that, so it's definitely the t. So because the t's are exactly the same, I can go through and rewrite that as minus the cosine to the 4th power of t. All right, we're going to go ahead and move on to factoring quadratics. So factoring quadratics with trig functions is the same thing as factoring in general. So if I go ahead and start with the cosine squared of x minus 2 cosine of x plus 1, it's really helpful for you to think about all of this as being u. But we don't pick up the coefficient, right? Because that's not what we're looking at. This is a coefficient of 1. So this first thing, this is the same thing as able to factor if you have u squared minus 2u plus 1. Now to factor that u, there's a coefficient of 1. The only two places that you could have that would be u and u. And the only choices I have for that 1 is going to be a 1 and a 1. But because that sign here is a negative, that's going to be a negative for both of them. So if I do this for and replace it back with what I have for cosine, that just becomes the cosine of x minus 1 times the cosine of x minus 1, or because they're exactly the same thing, the cosine of x minus 1 quantity squared. All right, we're going to go ahead and do one more example with the quadratics. So the next example I have for you, the quadratics, would be 2 cosecant squared of theta minus 7 cosecant of theta plus 6. Again, we want to think of this as u and this as u. Make sure you bring down whatever the coefficient is. So factoring this is the same as saying 2u squared minus 7u plus 6. Now, I'm going to go ahead and do a brief review of how I do and how I teach factoring. If you have questions on factoring, you can go to those videos for me. But what I always do with this is I go through and I do a times c. So a is 2, c is 6, so that is 12. And b, your coefficient of the middle term, is negative 7. So I'm looking for two numbers that at the same time I need to replace inside here. What will go here and here? Two numbers that at one time will multiply to equal 12, and at the same time add or subtract to equal negative 7. Well, those two numbers are going to go ahead and be 3 and 4. But because I need them to become a negative 7, they both need to be negative. All right, so then to continue factoring this, I always do it reverse order. It's FOIL backwards. First term, inside, outside, which comes from my factor x, and then my last term. So my first term here is 2u. The only choice I have for that is 2u and u. Now this is where that factor x comes in. That 3, negative 3, and that negative 4, they need to combine to be that inside and outside piece. So I ask myself, 2u times what will either equal negative 3, that's not possible, or negative 4. Well, if I go ahead and multiply that by a negative 2, so that will give me my negative 4u for the outside term. The inside then would be left with a negative 3. Now if I want to go back through and FOIL this out to check it, what would you get for the check? It would be 2u squared minus 4u minus 3u plus 6. Again, this inside-outside term always comes from the coefficients of what I had for that side factor of x. All right, so going back to what we were talking about before, we're not just trying to factor this, we're trying to factor 2 cosecant squared minus 7 cosecant plus 6. But all I need to go back through is replace what I had with u. So my final answer with this would be 2 times the cosecant of theta minus 3 times the cosecant of theta minus 2. Now, before you say that's difficult and I'm going to just skip those, do know for a large portion of what we're doing towards the end of the chapter is solving quadratic functions and equations with trig functions. So it's absolutely something you need to know how to do.